Hi friends, welcome to this 8th video on power spectral density. We are doing partial fraction method to estimate the average power of the process, or otherwise called as the mean square value of the process. We have already covered two problems. We will cover one more problem in this video. Given the power spectral density Sxx of omega, 12 omega square plus 157 divided by omega square plus 9, omega square plus 16, we'll have to find the average power of the process. We will begin with the partial fraction 12 omega square plus 157 omega square plus 9 omega square plus 16. Since this denominator is going to contain two linear factors, we will use two constants a for the first factor omega square plus 16, b divided by omega square plus 9. No hard and fast rule which one we will have to take first and which we will have to take second, because it's in a product and we are splitting it into fractions. Now my target is to find the value of a and b, but the problem we can see is everywhere we have omega square. This can be best worked out with our omega square being replaced by the simple constant called as u. So when I replace this omega square as u, then we have this as 12u plus 157 by u plus 9. I have replaced omega square as u. So the factor also now for the partial fraction becomes a divided by u plus 16 plus b divided by u plus 9. My target now is to find the value for a and b. So we can compare the numerator and get our answers using the comparison technique. Taking LCM as u plus 16 into u plus 9, we can cancel off the denominators, in which case numerator a will be multiplied or cross multiplied with the left out constant which is going to factor which is going to be u plus 9, and b will be multiplied with the left out factor which is going to be u plus 16. Now we have a linear relationship. This can be solved for the values of a and b by equating the factors to 0. So I can equate u plus 9 to be 0 and u plus 16 to equal to 0, and now find the values for a and b. When I substitute u plus 9, the first factor, to be equal to 0, what will happen? I will have this u to be equal to minus 9. So in this place of u, I replace it as minus 9 plus 157. A times of u is replaced as minus 9 plus 9 plus b is replaced as minus 9 plus 16. What will happen? This minus 9 plus 9 vanishes, moves towards 0. This is going to be 12 times of minus 9 plus 157. So 12 times of minus 9 is going to be minus 108. Minus 108 plus 157. So that makes it as 49 times, which is going to be equal to minus 9 plus 16. Minus 9 plus 16 is going to be giving us b, this value to be equal to 7, b times of 7. So 49 is equal to b times of 7. When you want the value for b, cross multiply it by 7. So 49 divided by 7. So we have the value for b to be equal to 7. So my value for b is obtained as 7. So I have got the first value for my b. The next target is going to get the value for a. How to get the value for a? Equate the second factor to 0. What is going to be the second factor? U plus 16. When I equate u plus 16 to 0, u will has to be treated as minus 16. In which case what we will be having is, take u as minus 16. So 12 into minus 16 plus 157 makes it as a into minus 16 plus 9 plus b into minus 16 plus 16. So now this factor minus 16 plus 16 makes it as 0. So 12 into minus 16, 12 into minus 16 makes it as minus 192, and we have 157 to be equal to a times of minus 16 plus 9. So that makes it as minus 7. So this makes it as minus 35 to be equal to minus 7a. So minus sign can be cancelled off. So this gives you the value of a to be equal to 35 divided by 7. So that makes it as 5. So what do I have for the value of a? A happens to be equal to 5. So I have got my target. I have my b to be equal to 7 over here, and I have the value of a to be equal to 5 over here. Now put it back in your factor, and now we can solve it either using the integration technique or inverse Fourier transform technique. For this problem over here, I am going to apply inverse Fourier transform technique. There is no hard and fast rule. We'll have to use this. It's only for the sake of convenience of our practice. So once we are comfortable with any one of the method, we can just go for it and then solve the problem right. So I have 12 omega square plus 157 by omega square plus 9, omega square plus 16, which I split it using partial fraction as a divided by omega square plus 16, b divided by omega square plus 9. what we obtained for the value of A we obtained as 5 and B we obtained as 7. Okay, so put it back in the partial fraction. So you have 5 divided by omega square plus 16 plus 7 divided by omega square plus 9. Now take inverse Fourier transform on both sides. Okay, so we are going to take F inverse on both sides, which means I am operating it as inverse Fourier transforms on both sides. This is because we know that Rx of tau is nothing but F inverse of Sx of omega. Why we need this Rx of tau? Because we want to compute the average power. Average power is also given by Rxx of 0. So I am going to find first for tau and then I will replace this tau to be equal to 0. So this is going to be the concept behind it. So I want F inverse of the partial fraction because it is F inverse of the given quantity 12 omega square plus 57 by omega square plus 9 into omega square plus 16. So when I take Fourier inverse to my left hand side, it is the Fourier inverse to my right hand side. So I will split it into two factors, F inverse of 5 divided by omega square plus 16 plus F inverse of 7 divided by omega square plus 9. Now we will be using the Fourier inverse formula which we have already learned, so that this becomes easy for us for estimation. So what do we know? So what do we know about the inverse Fourier formula? 2 alpha divided by alpha square plus omega square will be equal to e power minus alpha into modulus of tau. So we are going to apply this to each of the partial fractions which we have computed over here. So this becomes 5 divided by omega square plus 16. We will be applying it again and again for the second factor. But what we want is 2 alpha over here. So this constant 5 has to be taken outside. And now then we will have to replace the 16. How to replace this 16? I can replace 16 to be equal to 4 square. In which case my alpha for the first factor will be equal to 4. So for my first quantity or the first partial fraction, my alpha will be equal to 4. Now applying for the same, 7 can be taken outside. So I will have F inverse of 1 divided by omega square plus 9. How I can replace this 9 as 9 can be replaced as 3 square. So for the second case, alpha will become equal to 3. So for the first case, I will write it as 4 square and second factor I will write it as 3 square. So now after taking out our 5 and 7 common outside, I will have to balance my numerator with 2 alpha. What will be 2 alpha for my first factor? 2 into 4. So I need 8 over here. So I multiply and divide by 8 for my first factor. For the second one, I want 2 alpha. What is alpha for the second factor? It is going to be 3. 2 into 3, 6. 6 is required. So I multiply and divide by 6 in my second factor. So taking out this 5 outside, multiplying with 2 alpha, 2 into 4, multiply and divide by same 2 into 4. Take the 7 common outside, multiply by 2 alpha, 2 into 3, 6, multiply and divide by for balancing it with 6. So this is going to be my formula. Now I can apply this formula. 2 alpha by alpha square plus omega square Fourier inverse is e power minus alpha into modulus of tau. Okay. So applying the formula of inverse Fourier, I have this for the first category. I have my alpha to be equal to 4. Alpha equal to 4 for me, and for second category alpha is equal to 3. So I have 5 by 8, 5 divided by 4 2s are 8. The formula is now replaced with this e power minus alpha into mod tau. So minus 4 into mod tau plus 7 divided by 2 3s are 6. E power alpha is 3 over here, minus 3 into mod tau. So this is my value of Rxx of tau because this is a function of tau. But what is my requirement? My requirement is Rxx of 0. So what I'll have to substitute over here? I'll have to substitute tau to be equal to 0 in my above expression. So this gives me 5 by 8 times 5 by 8 times e to the power of minus 4 times of 0 plus 7 by 6 times e to the power of minus 3 into 0. We'll have to keep in mind what is e power 0. E power 0 makes it as 1. So on substitution, this gives me 5 by 8 times of 1 plus 7 by 6 times of 1. So now I am going to take LCM for 8 and 6. 8 and 6 makes it as 24. multiply with the left out factors. This has to be multiplied by 6 and this has to be multiplied by 8. Adding up what we have is going to be equal to 43. So the final answer for your average power or the mean square value, the question is going to be average power. Average power or the mean square value is obtained as 43 divided by 24. Thank you.